Thank you for joining me and giving me the chance to talk about fossil fuels and biofuels and their differences. As Lara mentioned, my background is in geology, and then I started studying petroleum engineering, so I'm familiar with fossil fuels. Um, so in general, the energy sources we usually divide them to non-renewable sources and renewable energy sources. Non-renewable, these are the terms that you see them and you hear them every day. Non-renewable energy sources are such as coal, natural gas, oil, and renewable sources are wind, solar, hydropower, and bioenergy. And I'm sure that one of my in the next talk, my colleague is going to talk about wind and solar energy, but I am focusing on bioenergy here. Well, there are different source for to get fossil fuels. The petroleums like coal, oil, or natural gas, that, as I said, they are non-renewable source of energy. It takes them millions of years to form. And you can imagine that how fast we extract them, right? Um, so technically, there is no way to replace these sources after we extract them. There are two different type of reservoirs, and we call them conventional and unconventional reservoirs, or conventional oil or gas. So let me just explain what conventional reservoirs are first. The conventional reservoirs are technically kind of like a little pool of gas and oil that form underground because of some geological formation, like if you can see that mouse, I'm moving it. It makes a cap and makes a cap and traps gas and oil underground. So this little balloon that is underground filled with oil and gas has really high pressure. And when we are drilling a well, imagine that you are just drilling a hole in a balloon. What happens is that because of this really high pressure underground, it just pushes oil and gas out. Very simple, very easy to produce oil and gas, right? There are plenty of these type of conventional reservoir oils um, that these days they are extracting it. People are extracting oil. Okay, but it will run out one day, and that day is not it's that far away. So since big oil companies and industrial companies, they figured out that, okay, these reservoirs are not going to be there forever. They looked for different type of gas and oil that has been trapped underground. Not all these reservoirs has this really nice pool shape. Sometimes gas and oil can be trapped in between of these rock grains in little teeny tiny pores. Those we call them unconventional reservoirs because it's not that easy that if the pressure difference by just drilling a hole, push the oil out. So what human did said that, okay, conventional reservoirs are not enough because we're gonna be run out of it pretty soon. So let's extract whatever is possible and it's available there underground. So a major called enhanced oil recovery form. Enhanced oil recovery meaning it means that the type of oil and gas that easily we cannot take them out of from the underground, gonna come up with some different methods to do that. So let me just bring some example of these methods. It's interesting. Um, One of these methods is that, as I said, these oils and gases are trapped in really teeny tiny pores in the rocks underground. So they drill a well and start fracturing the rock. Okay, and we are damaging underground already. We're fracturing the rock, and then these oil can run out, and then we can produce it. That's one method. Another method, interesting one, said it takes millions of years that oil to be formed, right? I don't have million of years, but I have like few years. What can I do? So what if I dig a hole underground and flow hot steam or some hot fluid there? In that case, that unmature oil that it still needs few more million years to form, I can cook them. People do that. They cook unmature oil underground and then push it out. That's another way. The other thing, you have all, there's something that you use it every day in your kitchen. Soap, right? Call it surfactants or soap. You can wash oil from their dishes surfaces using soap. I'm thinking, why not using soap to push that oil that is trapped underground out? So, drilling a well, pour as much soap as I can underground, and push the oil out. These are all unconventional form of oil and gas production. And I just gave you three examples because we're human beings, we need energy, fuel, and I can do it. Okay, I came up with these methods because I'm smart, right? Humans are smart. But these enhanced oil recovery is not cheap. It's very expensive and it's not beneficial. Okay, let's say that you don't care about your grandkids that they are going to be run out of fossil fuel. And I am rich enough to produce unconventional even oil and gas. Have you noticed your energy bill recently? That how much is keeps increasing? There are still other problems that these fossil fuels can cause. Every day in the news, we see that, okay, today is November 21st, and then the newest, hottest day of November has been recorded, right? So, global warming or air pollution, water pollution. Again, let's say I am a very selfish human being that I don't care about these poor animals that are don't have any part in ruining the planet and just think about myself. I have money, I can use fossil fuels. Okay, I'm gonna do this. But, well, I have a news for you. Burning fossil fuels creates these little particles in air. Something like, for an example of it is soot. That these little particle causes many problems for human beings, such as heart diseases, lung cancer, strokes, asthma, and etc. Well, so far, I'm talking for 10 minutes and it's been really, really dark. I know, scary, dark. Do we have any solution for this? Oh, before I pass to the solution, let me just scare you a little bit more. So, beside all those problems that I mentioned, there's something that we need to take care of it really in, as soon as possible. First of all, we have to manage CO2, the carbon dioxide in the air causing the global warming, air pollution, and etc. I talked about the energy and fuel problem that one day soon we are going to be run out of fossil fuels, and the providing energy is going to be very expensive. In addition to all of that, every day we are producing waste. So these ways, we don't want to live in a planet. We don't want our grandkids to live in a planet covered with waste and garbage. So is there any way that we can take care of these sequestrate CO2, take care of the CO2 in the air, solve the energy problem, and take care of our waste problem? Well, as I said, it was really dark talk so far, but good news that yes, we do have a solution. So bioenergy is one of the solutions. It actually is growing very fast. Governments are supporting it, and it's very, very promising. So what's bioenergy? Bioenergy consists of renewable energy that comes from biodegradable materials. What do I mean by biodegradable materials? These are materials that they can break down to harmless products. Unlike the suit that I mentioned that will cause lots of health problem, biodegradable materials will break down to something that's completely harmless. And also, that product process is happening using natural materials, natural stuff like bacteria. Okay, so far so good. One of the um, ways to produce bioenergy is using biofuels. I mentioned that there are wind sources, solar sources, they are all bioenergy sources, but I'm focusing on biofuels today. So biofuels are fuels that directly are coming from biodegradable materials. Biofuels are exactly kind of like almost exactly similar to fossil fuels because they are made of hydrocarbons. Okay, so what's the difference? What's the benefit? Well, unless fossil fuels, biofuels are formed from mostly waste, agricultural, commercial, kitchen waste. So that's how we make biofuels. Also, the emissions that form from burning these biofuels are not going to be as dangerous as fossil fuels. How to produce these biofuels? I will explain three ways of producing biofuels. By biofuels, I mean in a liquid way or a gaseous way or type or solid type of fuel that you can use it to produce energy. One of the way we call it pyrolysis. Pyrolysis is a process that uses feedstock and it will break down that feedstock in absence of oxygen. It means that if you're burning something without presence of oxygen, that's the pyrolysis process. But how it works? We can collect general waste. It can be medical waste, agricultural waste, or anything, any type of waste. Or can be the agricultural waste, usually we do some pre-treatment before using it. Those waste, we call it feedstock because that's what we are feeding our unit with. You're going to dump everything in a chimney of pyrolysis, the temperature goes up, and what happens is that after the process, we are having some products. What those products are going to be? The most direct one is heat. That process creates heat. You can directly use that heat in boiling water in your boiler or warming up the house. And also other products are these three main products: biochar, syngas, and bio-oil. I start with bio-oil. Bio-oil is technically an oil that you can put in an engine and use it, right? Syngas is type of gas that is a little bit different than natural gas because it's enriched in methane, hydrogen, and CO2. So we can burn methane. And biochar is a solid product of the process that has two main actually profits. One of them is that biochar is a really, really good fertilizer. You can add it to the soil. But main reason that we love biochar is because it can capture CO2. Well, before I move on from pyrolysis, I believe that most of you have seen using pyrolysis in a movie. I don't know if you have seen Back to the Future. I think it was Back to the Future 1, when Doctor was stuck in future and they were out of fuel, didn't know what to do, and just said that, you know what, I'm gonna open this chimney and bring whatever garbage and trash you can find and we can dump it there. That's gonna be our fuel. Well, this is pyrolysis system. It's very similar to what you've seen in that movie. Um, Gasification is another method to produce biofuels. It's very similar to pyrolysis, except that instead of uh, running it completely oxygen free, we are adding a little bit of oxygen to the process. Again, it will produce gases such as methane and hydrogen, uh, but with lower amount of biochar. These are real pictures of Uganda that has been taken last year. And this is a gasifier unit. In this village, the crops are the main waste that they didn't know that what to do with those that many of waste, what they want to do. Meanwhile, they didn't have access to natural gas. So they installed a gasifier unit in the village, dump all the waste, the crops waste, the agricultural waste there, and they produce gas and bioheat that the village people would use it. As I mentioned, biochar is one of the products of pyrolysis process. Biochar, we love biochar because it can capture CO2. It's carbon dioxide removal. So in using the pyrolysis method, we are going to go carbon negative, not even carbon zero, carbon negative. So it's capturing CO2. This is an image of biochar that has been taken a year ago. Um, This can be placed in gardens and on in rivers and waterbed. And as I said, it's a really good fertilizer and it's also removing carbon dioxide. Okay, let me move to my third process that you can produce biofuels. This is anaerobic digestion. Aerobic digestion is a method that takes care of the waste, but mostly kitchen waste, and turn it to syngas and again some type of fertilizer. But this time, instead of burning it or to increasing the temperature, we're using some bacteria. The bacteria are going to break down organic matter and then um, changing it, switching to gas, mostly methane. And some that just say that we can use it as a fertilizer. We have the exact same unit in our university, which is really nice. And we call it our blue egg. And this unit is actually functional. What we do, we collect the waste food from our kitchen every day. And so technically, I know every day what you have ate. Uh, and then we put it in our egg and produce gas, and that we can burn that gas in a little stove and boil some water and have a really nice green tea. Well, what do we do with these biofuels that we produced, oil and gas? As I said, we can use it, put it in an engine. Yes, we can do that. And also, there's a new type of engines, we call it micro turbine generations. This is a turbine instead of engine. Either put in an engine or a turbine. These are the fuels for these turbines. We're going to put it there, and that turbine generates electricity. Again, the these images has been taken in Uganda last year. There was a village that they used biofuel produce from the waste of the agricultural waste of that in that village. They put it in a gas engine, produce electricity that is stored in batteries, and then use it. These bungalows are village people's house, and they never had electricity before. But because of these new techniques, we bring batteries in the houses that they can use it. Nice, huh? So finally, I want to introduce our energy integration lab in the University of Huddersfield. We actually do all these in the house. We are building a site that we call it Energy Integration Lab. These units are anaerobic digestion unit, pyrolysis unit, even microturbine are separately in a house functional. They're working. But what we are going to do that this project has started 6 months ago already, and hopefully very soon in the spring, we're going to have a really, really nice site to visit. We're collecting food waste from our kitchen, put it in anaerobic digestion. We are collecting university waste and put it in our pyrolysis or gasifier unit. Then we're going to produce some fertilizer, very nice one that you can use it in the university gardens. We already are doing it. And then some gases, bio oils, and biochar. The syngas and bio oil then would be used in our microturbine produces electricity, and we are going to store those electricities and use it in the buildings at the university. Meanwhile, we analyze every product after each time, each iteration, whatever products we have, we're going to analyze it and then run some other tests, modify it. If there needs to some agents to be added, we do it, modify it, and put it back in a cycle. So what we have here, we are taking care of the waste in the house, and then produce some energy that we're going to use it, heat up our buildings. Um, the gas that actually produced from anaerobic digestion, we're using it in a little stove that we have, and hopefully we can open our own cafe using the gas that we are producing. Well, with that, we have a really nice team. And finally, I just want to introduce our team we're from School of Computing and Engineering, Applied Sciences, School of Business School in University of Huddersfield. And very soon, I'm hoping to invite all of you to view our um, running really nice on-campus energy integration lab. That I wanted to thank you for listening to me, and I would happily answer any questions that you have.
Hi, Gina. Thank you for that. I think the question comes from me, and it's me being nosy. I have
Oh,
seen I've seen the anaerobic digester egg near the science building, but what specifically can be put in it? You mentioned that food from the canteen goes into it, but is there specific foods that can't go in? Does what food go in sort of
oh, Laura,
result
yeah,
what comes out?
mhm, that's a really good question. Well, technically, our egg can eat anything, but some of these food it likes it, some it doesn't like it that much. For example, um, our bacterias, our egg, really like fat and protein because it produces more methane. Something that the egg doesn't like at all uh, is citrusy food. It doesn't like pineapple at all or any lemon because technically, you know that when we catch cold, we take our vitamin C's because vitamin C is good for killing bacteria, right? So any citrusy, anything sour like lemon will kill those bacteria in the egg. So we try to avoid pineapples, oranges, or lemon. other than that, it likes everything. But if we add, if we feed it with waste protein or, what it likes really, really much, the waste oil that they fry chips, that waste oil is, the egg really likes it because then it produces more methane.
Mm. Do you do that on a daily basis, weekly basis? How long does the process take from you putting in the waste from the canteen?
Um, it depends on how many students we have. So if there's a period of time that students are working on a project, they feel that they on a daily base, about 2 kilos of waste they can fill that every day. And after 2, 3 days, there's a blue bag behind that egg that is going to be filled with gas methane, and then we burn it.
Whereabouts do you what's it burned for specifically?
Oh, at the moment we just have a little burner that
Yeah.
we can just put our kettle there and boil some water. That would be nice. But our goal is that after I showed you the map of our energy integration lab, that we have a really nice site, and we are going to move the egg to that site, and that methane, the gas, is going to be used in a boiler or any stove, anything that needs energy or heat from burning gas. Yeah.
Thank you.
Oh, welcome.
Let me just check if there's any more questions.